Hello, this is Jim McKeeth, and welcome to this Code Rage 10 session on integrating new Windows 10 and WinRT platform features into your app. In case you missed the announcement, Microsoft unveiled Windows 10, the latest version of their operating system. It's a free upgrade for Windows Vista users and newer, and it's already running on 110 million desktops, laptops, and tablets. Windows 10 combines the best of Windows 7 and 8.1, so it gives you a great desktop first interface with great mouse interfaces, etc. And then when you move to a touch interface, it works great there as well. It's also making native Win32 and Win64 applications first-class citizens again, which we'll talk more about that in a little bit. So first, some of the new 10 Seattle features for Windows 10. On the RTL, we have WinRT API interfaces for a number of WinRT classes. We also have got the T Notification Center component, which is now available across all platforms. Contract sources, allowing your application to share data with other applications. Notably under FireMonkey, we have new MultiView Behavior and new TSplitView Behavior, as well as the ability to render with native controls. On VCL, we've got high DPI and 4K monitor support and a bunch of new controls: the activity indicator, search box, relative panel, switch view, split view. Both FireMonkey and VCL also have new Windows 10 styles. Now, the highlighted items you see here in the brackets are not specific to Windows 10. You can actually take advantage of these features across all Windows platforms. So, in the FireMonkey features across all the platforms we support. So that's great that you can leverage these on older OSs or other OSs as well. So what exactly is the Windows Runtime, or WinRT? First, a little history lesson. Now, I've done the best I could to make this accurate, but it's by no means complete. If you're concerned about things I may be missing or have dates not exactly right, you're welcome to present at Code Rage next year. Back in '93, Microsoft introduced Win32 as the API interface for Windows NT 3.1. When the VCL and RTL were introduced, they quickly took advantage of Win32 and had great interaction. So when you're developing with VCL and RTL, you could take advantage of all the Win32 features if you wanted to. In 2002, while WinXP was the primary operating system, Microsoft introduced .NET. .NET was their new Windows API. It was going to replace Win32 and be the dominant API on the platform. And Microsoft forecast that Windows Vista was going to be the beginning of the end for Win32, that .NET was going to be the API going forward and the only way to develop for Windows Vista. It's about this time that we saw the release of VCL for .NET, because the VCL for .NET was built on .NET so that users could take advantage of that .NET interaction and have first-class applications on Windows Vista going forward. Now, this is what Microsoft's forecast was, the end of life of Win32. The reality was Win32 continued on strong. In fact, .NET was found to not be a great solution on the desktop, but was instead really embraced on web development server side. So 2012, shortly after we saw the introduction of FireMonkey and the ability to take Delphi and C++ Builder applications across platform, we see the introduction of Windows 8. Now, Windows 8 brought with it another new Windows API, the WinRT. Microsoft announced WinRT was going to be the primary interface for developing for Windows 8 going forward. And everybody said, we've heard this before, and took it with a grain of salt. But the reality was WinRT had limited interaction outside of .NET. Microsoft had some flavors of Visual Studio that could talk to it through Visual C++. Special version of C++ could work with WinRT, but the majority of apps that took advantage of WinRT, that were the Metro type interface that was popular with Windows 8 and then had its name changed, were developed with C# VB all around .NET. Now we come to 2015 with Windows 10. Windows 10, we see a big shift with WinRT in that WinRT has been opened up, and you have this high level of interaction between Win32, .NET, and by extension, the VCL and the RTL. So Windows 10 has made Win32 applications, native applications, VCL applications, and RTL applications, and FireMonkey applications first-class citizens on Windows 10 because they have full access to WinRT. So what exactly is Windows RT or the Windows Runtime? This is the new default application programming interface. It doesn't replace Win32. It runs at the same level as Win32. Some features are available through WinRT. Other features you're going to access through Win32. That's fine. They coexist side by side. It's important to note this isn't to be confused with Windows RT, which was the ARM version of Windows that ran on ARM tablets, which has been end of life by Microsoft. This is WinRT, or the Windows Runtime. So the Windows Runtime is an object-oriented API, which is much different than Win32. It's also asynchronous. No calls to it will take longer than 50 milliseconds. If they do, then if the call could potentially take that long, then it is called asynchronously. It's COM-based, but it's a little different than we're used to with COM. And it's also important to note that it's not .NET, it's not managed code, it's a native code API. So in the RTL, our Windows runtime interfaces include 40 new units, or over 40 new units in the WinAPI namespace. This includes helpers to ease the creation of objects, so you don't get bogged down with a lot of different factories and set up and tear down. In fact, you end up writing less code with Delphi or C++ Builder than you would with C#, Visual Basic, or Microsoft Visual C++. And we're used to that with Delphi. That's why we love Delphi, is because we get a lot more done. Here is the listing of the new units in the WinAPI namespace. They're all found in source RTL WinRT folder. Actually, the system.win.winrt is a helper class. It's not found in that folder. It's a different folder, but the rest of these are found in that folder. I do want to point out the winapi.devices.bluetooth. This exposes all the new Bluetooth functionality in Windows 10 so that we can take advantage of beacons and Bluetooth LE in a much more elegant manner. So this is something great to have access to and to see what it unlocks for us in the future. So in Windows 10, we can take advantage of creating notifications from our applications. This is done through the T-Notification Center. So now the T-Notification Center exists and works across all 4 platforms: Windows 10, OS 10, Android, and iOS. So you can schedule notifications or post them immediately. They can, if they're scheduled, they can occur after your application is shut down, and these can tap the notification and relaunch the application. The notifications appear in the Windows 10 Action Center, and they've moved from the FireMonkey namespace into the system.notifications namespace. And so now they work with VCL, RTL, FireMonkey, all application types. One note is that if you want the notification to be able to relaunch the application, then your application needs to have a shortcut on the desktop or the start menu.
To work with WinRT on C++ Builder, you need to come into Tools, Get It Package Manager, and make sure the WinRT package is installed from here. So just hit install if you haven't already installed it. I'll show you install it real quick for you so you can see how easy it is. Install, agree, downloads it, extracts it, adds the environment variables, and now you're all ready to go for WinRT and C++.
Here's the Windows 10 notification sample that ships with 10 Seattle. So we can show a notification here. We can cancel that notification. We can show another notification, which is notification 2. And if the user clicks on it here or clicks on it here in the notification center or the action center, we get a notification back in our application on which notification the user clicked on. The showing is done here with the code you see here, and then canceling is done by notification name, which we provide here, or we can cancel all, which cancels all notifications irregardless of their name. So another new feature that WinRT brought was the idea of share contracts. Share contracts allow applications to share data with each other, much like you did with the share sheet on mobile applications. In Windows 10, because WinRT is available to desktop applications, you can now do share as a source from Delphi and C++ Builder applications. This allows you to share text, images, links, etc. You share the data with meta information that specifies titles, body, attachments, etc. There's two ways to share things. You can share it through the T sharing contract VCL component or the T share contract RTL class. So the RTL class can be used from FireMonkey or any non-VCL applications. So here's the sharing contract in action. When your application shares, the charm bar appears, and the user is able to select what application of available applications they want to share the data into. Here's an example of sharing data in C++. It's just a matter of setting all the properties and calling init sharing. So let's take a look at some of the new visual components we have. We have the new TMultiView Behavior of navigation panel. This allows the panel to collapse into this narrow band instead of collapsing completely so that it's still visible. I really like this because the user can interact with it and see what's available to them there without having to expand it out completely. It's the default for Windows 10, but it's actually available across all platforms. Also, we've brought the native rendering from iOS to Windows. So on FireMonkey controls, you can specify the control type of platform, and this will do native rendering by the OS, as opposed to doing the GPU rendering by FireMonkey. And we have the FireMonkey Windows 10 styles. This includes the dark style, the blue style, and the light style. The new activity indicator is similar to the ANA indicator on FireMonkey, and it gives you the ability to display to users that something's happening, but you don't know how long it's going to take. Very configurable for flexible display of activity. So here's the activity indicator sample that we provide. You have different indicator types. I really like those momentum dots, but you can do the rotating sector or the sector ring. So you've probably seen all three of these in use on Windows 10. That's probably my favorite. There's different sizes as well. There's small, extra large is more visible in this demo here. And you could do white or black. So the white shows up really well if you're theming, for example, with the dark Windows 10 dark theme. You can change the delay as well, so you can go with really slow or really, really fast. The new relative panel is really cool. It allows you to specify that a control is relative to another control. So instead of setting the control's positions absolutely, you instead say this button's always to the right of this edit box. This label's always to the left of the edit box, etc. So this is the new T-relative panel sample that we have. So the cool thing about the relative panel is besides, you can specify the location absolutely like you could before with left and top, or you can specify the location relatively. So you can say I want the edit aligned to the left of the panel, or you can say I want the edit to align with the left of the button. And so now if the button moves, which right now it's set up to be draggable, the edit box stays aligned to the left of the button. And I can say I always want it to be above there, like this. So this is configurable. This behavior is changeable. So see now the button's aligned to the edit and the edit's aligned to the button, which is kind of interesting. So usually what you're going to do with this is you're going to set it up so that you can say you want your button always to aligned to the right of or to the left of the edit box. Right, so let's see, we're going to take this one, remove that alignment on there, and we want the button align with the top of the edit box there. There we go. So we want the button aligned to the middle of that. And so now if the edit ever gets moved, that button's always going to be pinned right to the side of it. So this is great if you want to have your UI be flowing or reconfiguring, and you want to be able to know that this button is always going to be assigned to the right of the edit box. So previously, I did tricks where I put like this on a panel, and then in the panel I put the button aligned to the left and the edit box aligned to the client or something like that, and then did use panels, nested panels. So now you don't have to do that. You can just give these relative alignments to your components and know that they'll always be where you expect them to be.
So let's go into a little more detail of working with the relative panel. So I have a relative panel down here and I have some various components on the relative panel. And if you select one of these components and scroll down to the bottom of the object inspector, you'll see it has an additional set of properties here that are injected by the fact that it's on the relative panel, which is really kind of cool. So if I want to make this label always to the right of the edit control, and come down here and say align vertical center with, I just have the label, align vertical center with edit 1. And so now if I move the edit, it's always going to be in the there, but it's not necessarily just to the right of it. So I can come down here and say label 1, right of edit 1. Oops, left of edit 1, because I know my left from my right. Okay, so now as I move edit 1, that label's always going to be just to the left of it. So now at design time, it's easy to work with through these properties here. At runtime, the relative panel has a collection called the control collection that you can iterate through. So you can go control collection dot index of button 1 and find out what button 1's index is in the control collection, and you say control collection square bracket button 1, or whatever the index of button 1 was, in order to access these properties for button 1. So at runtime, button 1 does not have these properties in your code. You can't say button 1 dot align with top of panel. But if you say relative panel dot control collection index of button 1 dot align with top of panel, then you can access that. Now, if you're a C++ developer, then it would be arrow or dash greater than align with top of panel. So there you go. Pretty easy to work with. There is some documentation in the doc wiki that talks about precedence of alignment rules, so it's real important to understand this because you could give conflicting alignment rules, and it tells you how to resolve those and what the order of operations is. So it's very, very good to, very worthwhile to review this when working with the relative panel.
The new T-search box includes both an audio and text indicator. When the user enters what they're searching for, the onInvoke search event occurs, and at that point you can filter or search other controls for the user. This is the T-search box sample that we ship. It has two different indicator modes, audio and text. In text mode, you can type text in here, and then either hit enter or tap the search button. And this causes the onInvoke search event to fire. And we see here all we're doing is displaying that it was a text search and they searched for hello world. In the audio mode, you can't type in here anymore, but you click the button and you just get an event that says audio search on an audio invoke search started. The supports BiDi, left to right, right to left, and also I'll just real quickly show you some of the Windows styles we have. Here's the blue style, here's the dark style, here's the Windows 10 style. New control is the TSplitView. This is a VCL implementation that is similar to the MultiView. I love the MultiView. I'm excited about the new TSplitView because it brings this great new UI paradigm to VCL applications as well. This is the split view sample. So it has a few different modes of operation here. Right now with this button set up to close or open the split view. And so if you see here, the split view is selected, and you see the little blue dots here. The split view is this area here, which in this case contains these menu items, but the split view can contain anything, and then you can change its behavior. So right now it's set to collapse completely, but when it's closed, we can make it so it goes to compact style. So now it just displays the icons, which I think this is a really slick format here because I can still click these icons and get the events from it. You can go to an overlay mode instead. So let's go like this and now overlay over the top of it. We can do the compact mode and overlay where the collapsed mode is small and it overlays over the top. Place it on the left or the right, and you can control the animations. Very cool, very nice new UI paradigm to incorporate into your VCL applications. There's the new VCL TToggleSwitch. This is similar to the FireMonkey T-switch. It has custom captions, custom colors, and resizable elements. It has a state of TSS on or TSS off. And of course, the Windows 10 VCL Style. This gives you the choice between dark, blue, and light styles to give you that modern UI look and feel on Windows 10. Now let's talk about the Windows Universal Platform, or UWP, and the effects of the Project Centennial Bridge. The Universal Windows Platform is kind of an umbrella name that includes a lot of things, but specifically it includes the ability to distribute your apps through the Windows Store. That's probably the biggest thing, is that you can have your app be installed and uninstalled and updated in a clean manner. It's all sandboxed safely, so the user doesn't have to worry about your application leaving behind DLLs and text files and configuration files all across the system. With being a Universal Windows Platform application, an application gets full access to the Windows RT and all platform features. And it has a universal app ID that uniquely identifies that app. So that's where Project Centennial comes in. This is a bridge that's coming out from Microsoft. They've announced it and already started talking about it. That's going to allow Win32 and Win64 based applications, native applications, to run as Universal Windows Platform apps. This gives all the advantages of the UWP and Windows 10 WinRT to desktop native apps. This does this by bundling up your app and all its support files into an app X. And then your app thinks those support files have been deployed to the system directory or wherever it is it expects them to be, because the I/O is mapped to the location in the bundle. But your application runs without virtualization. It's only when it's making the I/O calls to these bundled files that those calls are remapped. The rest of the time it's running natively. So there's no virtualization, there's no overhead that's going to slow your app down. It's running purely native with its maximum performance. The only limitation that they're expecting, well, there's a few other slight limitations, but the big limitation you might hit is that your app cannot escalate to admin privileges. So if your app needs to write to the program files directory or write to the Windows system folder, it's not going to be eligible to be used under the Centennial as a UWP app. To learn more about Project Centennial, you can check out this session from Build 2015. It's very informative, telling you about how they're expecting Centennial to work. It has a huge disclaimer that this is beta, not even released yet, so it could change. You can also sign up for updates at the URL there. So in summary, Windows 10 is making Win32 and Win64 applications first-class citizens again. It's got a huge installation, it's moving fast, and it's a great opportunity to be a Delphi or C++ developer. VCL remains the best Windows client library. It has been since the beginning. You're more productive, you get more done, and you build great, fast apps. Thanks to all the new Windows 10 enhancements, your apps are going to be able to take advantage of all those great new features in Windows 10. FireMonkey Desktop is also significantly enhanced, also to be a great consideration for Windows 10 development, especially when you're looking to go cross-platform. Rad Studio is committed to keeping focus on Windows 10 and the Windows RT.
WinRT, there's, as Jim mentioned right up front, there's a whole set of WinRT runtime library interfaces, wrapper functions, and so on, wrapper classes. So if you have 10 Seattle, you can go into the source code, the RTL, and there's a whole subdirectory for WinRT of sets of components, of sets of classes that let you do a bunch of things, and we use some of that with some of the Windows 10 specific things like notifications and so on. We use those things under the covers, and we have samples for that. I think Serena showed some samples earlier on yesterday about some things you can do, and it was also covered in the product address. So it's good for C++ developers to be able to use WinRT, and we'll keep looking at these other projects that are work in progress at Microsoft, and we're an integration partner and API licensee. So we're on top of Windows. Windows is in our DNA. DOS was in our DNA back in Turbo C, and then we went to BC++ for Win31, then Win3031, Windows DNA again, and Windows all the way through. I mean, CBuilder and Delphi, even though we've got things like Linux on our roadmap and we do multi-device, we know that Windows, not only for running our IDE and some of our technologies, Windows is just at the core of everything that we think about, but we're branching out into other platforms as well.